Hey y'all. Today we are going to continue with our discussion of real world problems, and we're going to do a little bit of chemistry. Now, they're not all chemistry problems, but I call these problems chemistry type of problems because you'll understand in a minute. It's talking about acids, it's talking about metals, it's talking about solutions, and you'll see what I'm talking about. So I have 3 problems for you. Make sure you copy these down, the problems, and then the work. You want to combine 2 types of fruit drink to create 24 kilograms of a drink that will be 5% sugar. Fruit drink A is 4% sugar, and fruit drink B is 8% sugar. How much of each type of drink do you use? So that was a lot of information. Let's break it down. We have fruit drink A, fruit drink B. They both have different amounts of sugar, 4% and 8%. We want to mix them together to form a 5% sugar drink. So this is why I call these like chemistry problems, because we're mixing percentages of different things. So to solve these chemistry type problems, we need to set up 2 equations like we've been doing. We have to define the variables. So we're going to define x and y as x is going to be the amount of drink A, and y is going to be the amount of drink B. That's what we're trying to find, how much of each type of drink. So x represents the amount of drink A, y represents the amount of drink B. The total we want to create is 24 kilograms. So we know that the amount of A, which is x, plus the amount of B, which is y, is going to equal 24. So that's like your sum equation. We know that A and B together is going to be 24 kilograms. Now we have to use these percentages. And drink A has 4% sugar. So in front of x, because that's drink A, we're going to write 4% as a decimal. So 4% in drink A plus B, drink B has 8%, so 0, 8. 8% in drink B is going to equal how much sugar do we want in our total? Well, we want 5% in our total, and that is going to be times 24, because again, we want 24 kilograms in our total. So first we need to go ahead and do that, 0.05 times 24, and that is 1.2. So 5% of 24 is 1.2. Now you can see I have set up a system of equations. X plus y equals 24, 0.04x plus 0.08y equals 1.2. We need to solve these equations, and you have graphing, substitution, and elimination. These, the way they're set up, are really not good for graphing at the moment. You could choose to do substitution, or you could do elimination. If you wanted to do substitution, then you would need to solve one of these for x equals or y equals, and then substitute it in. I am just going to do elimination. I'm going to multiply this whole top, and you can choose to eliminate the x's or y's. I'm just going to eliminate the x's. So I'm going to multiply it by a negative 0.04. And I'm going to distribute it all the way across. So I get a negative 0.04x, a negative 0.04y, and negative 0.04 times 24, negative 0.96. Now I'm going to add these together. I'm going to add them up, and I can see that my x's are going to eliminate because I have a positive and a negative. They're going to eliminate. Now I'm going to add 0.08 plus negative 0.04, and that gives me a positive 0.04y, and then I'm going to add together 1.2 plus negative 0.96, and that gives me a positive 0.24. So I haven't done anything new or different. All I've done is I've just solved my system of equations by elimination. We have to divide both sides by 0.04 and 6. So y equals 6. That means I'm using 6 kilograms of drink B. 6 kilograms of drink B. I also need to go back and find my X value. So if I want to do that, I'm going to plug it in here. So X plus 6 equals 24. Subtract 6 from both sides, and X equals 18. So that means I want to use 18 kilograms of drink A. That probably should make sense to us because drink A has less sugar than drink B. So we want to use more of this less sugar to stay at a 5% sugar weight. So I set up my two equations and I solved. I got Y, and then I substituted back in to get X. Okay. Problem number 2. Copy it down. A 3% solution of sulfuric acid was mixed with an 18% solution of sulfuric acid. So we've got 3% solution and an 18% solution to produce an 8% solution. So this is what our end product was. They put together 3% and 18%, and that was our end product was 8%, 18 and 3. How much of the 3% and 18% solution were used to produce 15 liters? So we have a 3% solution, 18, and we got an 8. And then we wanted 15 liters of the 8% solution. So we have to define our variables. We're going to use an X and a Y. The X is going to be the amount of 3% solution, and the Y is going to be the 18% solution. So we have a 3% solution, that's your X, and an 18% solution, that's your Y. Those together, X plus Y is going to equal 15. That's how many liters we want, how many kilograms, however many milliliters, whatever. That is what we want, the value that's not the percentage. Now we have to take into account our percents of solution for the sulfuric acid. So this 3% solution is going to be on the X, so it's going to be 0.03X. 18% solution is going to be paired with the Y, so 0.18Y. And then we want 8% of the 15 liter solution. And now I have a system of equations. Now, again, the easy thing to do is go ahead and do 0.08 times 15. And, oh, that's weird. It is 1.2, again, weird. And again, you could use graphing, substitution, elimination. I'm going to choose elimination, so I'm going to multiply my whole top equation by negative 0.03 because I want to have the opposite of this coefficient. So that's a negative 0.03x minus 0.03y, and then negative 0.03 times 15. I keep typing negative 0.03 times 15, negative 0.45. Now I can add my I can add my two equations. These are going to eliminate. So I have 0.18 plus negative 0.03, 0.15y, and then 1.2 plus negative 0.45. And again, this is not new. This is the elimination that we've been doing. I'm going to divide by 0.15 on both sides. And y equals 5. So in this problem, it's 5 liters of the 18% solution. I need to substitute it back in. So x plus 5 equals 15. Subtract 5 on both sides. X equals 10. So it's 10 liters of the 3% solution. So the question says, how much of the 3%, well that was 10 liters, and how much of the 18%, that was 5 liters. And when you mix that together, you're going to get 15 liters, that is 8% solution. Alright, so copy number 3 down. One antifreeze solution is 10% alcohol. Another solution is 18% alcohol. How many liters of each solution should be combined to create 20 liters that is 15%. So again, we have an X value, that is your 10% solution, and your Y value is your 18% solution. X plus Y is going to equal 20, because that's how many total liters we want. Now we have to use our percent. So we're going to use 10% of X, 0.10 or 0.1, and then 18% of Y. And we have to multiply, remember? 0.15 times 20. 0.15 times 20 is 3. So I'm going to go ahead and put a 3 there. Just like I've done with the other two examples, I'm going to multiply this by negative 0.1 or 0.10, the same thing. Multiply it to distribute. I get a negative 0.10x minus 0.10y, and then negative 0.10 times 20 is negative 2. I'm going to add these equations, and as you can see, my x values eliminate, and I've gotten 0.18 plus negative 0.10, so that's 0.08, equals 3 minus 2. 3 plus negative 2 is 1. Whoops, I forgot my y. Divide by 0.8. Whoops, divide by 0.08. So 1 divided by 0.08, and that is 12.5. So we need 12.5 liters of our 18% solution. Then I'm going to substitute it back in. X plus 12.5 equals 20. You subtract 12.5 from both sides, and X is going to equal 7.5, I think. So that means we want 7.5 liters of our 10% solution. And this should make sense because we want a total of 15. So if we're adding together 10 and 18, we're going to want a little more of the 18 because we want to get higher, closer to 18. 15 is closer to 18, so we're going to add a little bit more of the 18 and a little less of the 10%. So I've given you 3 examples of these chemistry type problems, and we will practice more in class.